Hello everyone, I'm Robert with Amazon Web Services, and today I'm going to give you an introduction to GraphQL. We're going to cover what GraphQL is, the history of GraphQL, we'll compare GraphQL to REST, I'll cover what I think are the three superpowers of GraphQL, and then we will dive deep into authentication and authorization, and finally we'll close with a discussion on when you should use GraphQL and how you might get it into production. Let's begin with a demo. Here, we're going to learn GraphQL by way of an exercise. Now, let's say that I want to fetch the names of all of the characters that appeared in Star Wars movies with Luke Skywalker. And of course, in order to do this, I need an API. I have two APIs here. One is a REST API and the other is a GraphQL API. They have the exact same data. And what I'm going to do is click on this REST API here. And if I do that, I can see that I have a resource here that represents Luke Skywalker. This is JSON. The browser has just formatted it so that it's a little bit easier to read. And as I can see here that this JSON document has a bunch of fields like height and mass. But notice that height and mass are actually expressed as strings instead of numbers. That's just an implementation detail of this API, but it matters to me when I consume this API. And then take a look down here. We have the home world field, we have the films field. These are URIs. And if we were navigating this as though it were a web page, it's very intuitive what we could do with this. We can click on them. But before I actually click through, this films field is the exact data that I need. I said I wanted to fetch the names of characters in films with Luke Skywalker. Here are the films. But before I click on this film link, what is the data within this film? What is the structure of that JSON document? What are the types of its fields? I don't know. And there is no standard way in REST to know. So I'm left with a problem. I have to make the request in order to get an idea of what the response is going to look like. And this introduces challenges when I'm building applications around this kind of requirement. Well, in any case, let's cheat here and click on one of these links and see what the actual structure of this document is. All right, so I've got a new tab open and you can see this is one of the movies, this is Return of the Jedi. And there we go, we have the characters array and we have a bunch of other data though. And this is a phenomenon known as overfetching, where this is the data that I wanted. I want the characters array, but I got a bunch of other data, like that opening crawl text. That's not ideal. And we'll talk about the constraints of the network and how expensive network requests are later on in this presentation. Suffice to say that this network request included data that I didn't ask for, nor will I make any use of. Now, given that we have all these characters, we can just click on one of these character links. And hopefully this looks a lot like, indeed it looks a lot like the Luke Skywalker link. We have height, mass, and then we have the name. And again, we have this overfetching phenomenon. A lot of data coming back that I don't actually need. I actually need only one field out of this response. It's a little wasteful that I'm going to get all this data back for every single character. All right. So with that, we kind of know how to write the code for this. And indeed, here it is. If you look at this run REST function, we start with the URI for the Luke document. We fetch the characters. We fetch the character, and then we fetch the films that character appeared in. It's just a helper function here that I wrote for fetching them in parallel. And then we go on and we do a little bit of manipulation. We get rid of the duplicates, and then we do a little bit of mapping. And we're left with all of the names of the characters that appeared in movies with Luke Skywalker. Just about a dozen lines of code. Very simple, right? And anybody who's used REST APIs, you know what it's like to kind of follow through these hypermedia links on documents. Now let's take a look at how we achieve this in GraphQL. What you're looking at here is GraphQL Playground. GraphQL Playground is one of the GraphQL IDEs. And using GraphQL Playground, we can author the GraphQL request on the left-hand side of the window. When we hit the play button, we're going to send this request to the server, and the server is going to process that request and send us back JSON. If the server encounters an error, it's going to return an error as well. In order to know what we can write for the request, I'm going to open up the Schema tab here. And in the Schema tab, you can see all the types and their fields and their relations to other types. And what we're looking for here is the person type. There it is. So with the person type, you can see without ever making a request, the Schema tab is telling me, hey, there's a URL string on here, there's a name string on here, there's height, name, and they're all typed. I know what the type and the structure of this document is before I ever make a request. And then for Homeworld, notice that instead of URI, I have a type called planet. And I can look up right below here what fields are on the type planet. Now, in order to construct the query, I'm going to locate the query type, and this is the entry point into the graph of data. And that means that I can start with any of these root fields within the query type here. And in order to locate Luke Skywalker, I have this handy person root field that takes as an input parameter name. And now I can start typing my query. So I start with the keyword, which is the operation type, and I optionally give it an operation name. The name is optional, but is very helpful because it's going to help you debug and track the lifetime of this query on the server. And I said I needed to pass in the name, so I'm going to specify the root field here first, which is person, and I need to pass in name, and I want to fetch Luke Skywalker. Now, what follows is a pair of curly braces and then the selection of the fields into the person. So we saw the person object earlier in the schema. We can choose any of those fields and we can specify that as the selection set. I'm just going to get name right now as a sanity check that we are in fact talking about the Luke Skywalker person within my graph of data. And when I click enter, indeed, that's the data that I get back. Just a simple sanity check. Now I can also select into films, which is what I actually want. And because films is an array, I have to specify a selection set for every single film. What do I want out of that? Well, let's pick title first, and you can see here's the titles of all the films that Luke Skywalker appeared in. But we actually want characters, so I'm going to replace that with characters. I'm going to fetch the name, and there you go. Problem solved. Now the key distinction here is the fact that the response came back with only the data that I asked for, no more and no less. This is the exact data I need. There's none of that opening crawl text. There are no species, vehicles, arrays. This data is as efficient as it gets. And in fact, we can see that when we run these two functions. You can see that the GraphQL function is much faster. Why is it faster? Because we are executing one network request versus many, many more network requests. In fact, let's take a look at the network tab over here. When we run that REST function, check this out. Almost 100 network requests because I keep following those hypermedia links. I keep underfetching, right? That's why it takes so long. But when I run the REST request, a single network request with the exact data that I need. That's the difference. That's what we mean when we talk about efficiency within GraphQL. All right, back to the slides. So, what did we just see? Well, we saw that we created a GraphQL document, we sent it over to the server, and we got back a response. What that should tell you is that there are some rules. Remember when we started that GraphQL document with the operation type query, and then we gave it an operation name, and then we had some curly braces that had to be matched. All of those rules are defined in the GraphQL language specification. In addition, we had a schema, which defined all the different GraphQL types for the Star Wars API. And the schema is domain specific. It varies from GraphQL server to GraphQL server, but the language specification does not. And finally, of course, we had a server that was running and listening to all these requests. And by the way, the demo for this is going to be at the end in the resources slide. You can run this yourself, you can play with it, you can change it. So it's also instructive to talk about what GraphQL is not. When you get back a JSON blob like that with the exact data that you want, it's tempting to think that GraphQL is a client-side state management solution. It is not. It will not replace Redux. It will not replace Relay. It's also not a good solution for binary streams. And I'm talking about when you break a file into chunks and you have a stream of binary data. Of course, you can encode that in base64 and return it as part of a JSON document, but that's not ideal. Don't confuse it with the Facebook Graph API. And then backing this, there's no restrictions in terms of databases. You can use it with any database. You can use it with no database. It's not limited to the JavaScript ecosystem. And in fact, on the back end, if you want to run a GraphQL server, you have your pick of any popular language. Every popular programming language on the back end has a GraphQL implementation of some sort. On the front end, you don't just have to use it with React or web applications. In fact, GraphQL's benefits shine brightest when you combine it with a client that is statically typed like iOS or Java. And then, of course, at the transport layer, it is not limited to HTTP. In fact, if you choose HTTP, you're not going to get the full benefits of the subscription type. All right, so we've mentioned GraphQL operations a few times, and there are three. The first is the query operation. The query operation models a read. And there is also, of course, a mutation, which models a write. The reason it's called a mutation is because it mutates server state. If the mutation executes successfully, something about the server state is expected to have changed. And the final operation type is the subscription operation. And you can think of a subscription as a long-lived query. The client sends a request to the server, and the client and the server keep that connection open for an extended period of time, during which the server can send back data over that subscription to indicate that an event has occurred. And the subscription is especially good at modeling real-time operations. So for example, you might open a subscription and say, I would like to subscribe to new chat messages in any chat room that I'm in. And then as a result, the server can push payloads like, hey, there's a user that joined this chat room, there's a message that was posted in this other chat room, and you can see how that can be very intuitive for building real-time applications. So how did we get to this point? Well, it turns out that GraphQL has a pretty interesting history. The first version of GraphQL was built by 3 engineers at Facebook way back in 2012. It was built by Lee Byron, Nick Schrock, and Dan Schaefer. And they built it because the REST architectural style just wasn't cutting it for Facebook's mobile applications. Mobile applications, that's the key here. We're going to come back and see why REST APIs are not good for mobile applications. And then after years of iterating on internal usage of GraphQL, GraphQL was open sourced in 2015. But instead of just taking the internal version of GraphQL and turning it into an open source project, the team really took a deep look at what worked, what didn't. They made a lot of tweaks, and what resulted were actually 2 projects. The first project is the GraphQL language specification, and the second project is GraphQL.js, also known as the reference implementation. This is the reference implementation for the GraphQL language specification, and it can be easily combined with something like Express to create a fully functional GraphQL server. And then since 2015, GraphQL has seen a lot of uptake and rapid growth, especially at large tech companies. In fact, Amazon is one of them. I think aside from Facebook, Amazon is the second largest tech company that uses GraphQL extensively. And as a result, a lot of discussion occurred around, well, okay, this project originated from Facebook, but it's a utility. How can we make sure that GraphQL continues to evolve in a healthy way without undue influence from commercial interests or because one company invented it and is extra big? And those discussions led to the formation of the GraphQL Foundation in 2018. And the GraphQL Foundation is a part of the Linux Foundation. It is a neutral third-party governing body. And the purpose of the GraphQL Foundation is to ensure the healthy evolution of GraphQL and its ecosystem. And I'm very proud that Amazon is a founding member of the GraphQL Foundation. Now, let's switch tracks a little bit and talk about GraphQL versus REST. The reason why I'm doing this is because there are so many API technologies out there. And it becomes challenging to try and understand, well, how does A compare to B? How does B compare to C? They all have very interesting trade-offs with one another. And it really doesn't do this conversation service when we keep privileging REST. So I'm just making the problem worse in some sense. But the reason we keep choosing REST is because REST is ubiquitous. Everybody knows what REST is or thinks they know what REST is. And therefore, it's actually a good way to transitively talk about the capabilities of GraphQL with respect to these other API technologies. So here we go, GraphQL versus REST. However, I want to emphasize something. As we do this, I want you to think about these comparisons in terms of trade-offs. This is not a scorecard. Do not be tempted to tally up which row has more yeses at the end and declare a winner. It's not that simple, all right? So the first thing we'll start with is a shared definition. If you ask 10 people in a room to define what REST is, you're going to get 20 different answers. The reason is because REST, and by the way, we have to define REST in order to tackle this, but what I mean by REST is representational state transfer as defined by Dr. Roy Fielding in his dissertation in 2000. And when it's applied to an API, it means it's an API that applies all 6 of the REST architectural constraints. Yes, even the uniform interface constraint and the hypermedia as the application of engine state constraint, also known as HADIOS. Those are the 2 most opinionated parts of REST. And a REST API, by Roy's definition, is one that abides by all 6 of these constraints. Now, the degree to which these constraints are observed in the wild is all over the place. We have APIs that call themselves RESTful, but are really just JSON being transported over HTTP. And even if you take two APIs that do implement the hideous constraint, they're unlikely to share the same capabilities in terms of critical features like linked resource annotations. So I think it's safe to say that REST has no shared definition, at least not in any concrete sense. But GraphQL is not like that. Given a GraphQL endpoint and a schema, you know exactly what is and is not a valid query without even having to run it. And you also know the shape of the response. The second major difference comes in terms of the conceptual model. Representational state transfer talks about the resource, and you can think of the resource as a virtual file on the server. As a result, when you expand the REST API, you're talking about different URIs for addressing different resources. And in some ways, yes, you can form a graph of data by having hypermedia links from one resource pointing to another. But GraphQL makes this model explicit. It just says that the core conceptual model is a graph. It's nodes with edges and fields. And this is going to matter a lot later. Now, another result of these organizing models is how GraphQL and REST deal differently with federation. In REST, this becomes a huge advantage. And what I mean by federation is when you try to link resources between two domains. So you can go make a Facebook post and it can link off to an article on Wikipedia, which then cites something from New York Times. All of these have different domains in the hypermedia link. And that's great because that's what makes the web so interesting. It's what makes it so diverse. But with GraphQL, you have a centralized organizational model, which means that all the data you get out of a single GraphQL endpoint is for one consistent schema, for one domain, for one small part of the web. And linking data across GraphQL schemas usually falls back into relying on URIs. And there are some solutions in the works, for example, like federation solutions. But again, those are all generally dealing with situations where you're linking together different GraphQL endpoints that are themselves consistent with one another. Another difference is this concept of related operations. So in REST, there's a concept called manipulation through resource representation. And this says that when you're looking at a document, that document also includes all the hypermedia links to manipulate it. So if you're looking at a document for an airline ticket, it includes the hypermedia links to cancel the ticket, to rebook the ticket, to change your name, all of those, just like you would need in a web page. But in GraphQL, there's no such concept. When you're at a particular node in GraphQL, there's no standard or built-in way to say, hey, what are all the commutations and queries that I can use to affect this document? And finally, well, actually not finally, but importantly, we have the ability to perform introspection. And you can think of introspection as reflection for your API. And we saw that with GraphQL Playground, the IDE, where we could pull down the schema and ask, hey, what are all the types and what are all their fields and what are their relations to one another? That uses something called the introspection query, which basically tells you what is this API, what's going on here. And you can't do that with REST. Now, some of you might say, yeah, you can do it with Swagger, but Swagger is not REST and REST is not Swagger. That's an important distinction to make. Now, we also have data typing. We saw that with the schema, you get types. REST doesn't have any concept like this. And then finally, we have differences in real-time capabilities. GraphQL supports real-time capabilities as a first-class citizen with the subscription operation. REST does not. So that said, there are so many challenges to building modern APIs. We won't have time to cover all of them, although it makes for a very interesting conversation. I'm going to focus on a couple of what I consider GraphQL's superpowers. The first is efficiency. GraphQL is going to help you build more efficient APIs. Full stop. And in order to talk about efficiency, we need to talk about how expensive network requests are. Modern networks are really slow. And if you can ever avoid making a network request, you have to try to do so. Because if you can use data that's on disk, let's say, you can read a meg of data. That's a lot of data from a modern SSD in about 400 microseconds. A whole meg of data. But if you have to go to the network, a round-trip packet from the US to Europe under ideal network conditions is 150 milliseconds. That's a factor of hundreds of times difference. That's like the difference between getting next day delivery from Amazon versus getting next year delivery on Amazon. That's the difference of performance when you need to go to the network. So you want to avoid making network requests. To make matters worse, I said ideal network conditions, but there are a lot of mobile devices all over the world that are many years old, and they're connected to networks that cap out at sub 2G. And these networks are unreliable, they'll drop packets, they're even slower. And you've experienced this even if you live and work in the first world. If you go to the airport, Wi-Fi there is usually awful, right? So you know exactly what this feels like. And that's why you really want an API that is as efficient as possible. And we saw that with GraphQL, you can request all the data that you need up front. And you can say, this is the data I need, no more, no less, please give it to me. And that also helps reduce client-side complexity in terms of client-side joins, error handling, and retry logic. Now, the second superpower of GraphQL is type safety. And we saw that when you have a schema, you can annotate the types and the shape of every single node in your graph. And this improves predictability. This can save you from making a whole bunch of bugs, right? It's just like, why do people like TypeScript when they have JavaScript? It's because it adds a lot of type safety, and type safety is a kind of test. And this works exceptionally well with native clients like iOS and Android devices that use Objective-C and Java respectively, and those are statically typed languages, which means that you can use code generation to introspect your GraphQL API and then generate client-side type-safe code bindings, and then that can improve your dev test feedback loop. The final and third superpower of GraphQL is domain modeling. Now, of course, again, this is my personal opinion. And when I say domain modeling, I'm referring to the book called Domain-Driven Design by Eric Evans in 2004. And in this book, Eric says that both technical and non-technical people, when they're solving a business problem, they end up building something called a ubiquitous language. This is just plain language that they use to describe the business entities, processes, and relationships. And all this means is to say that when you write a GraphQL query, it is more intuitive than if you were trying to talk about this in terms of a database query or if you're trying to talk about it in terms of REST. The litmus test is if you have a non-technical person on your team, let's say a non-technical program manager, put in front of them three things: a REST API request, a SQL query, and a GraphQL request, and ask them which one makes the most sense. And if they can read it, whichever one they find most readable, whichever one they might find more intuitive, is the one that is the best for domain modeling, because that means that it is most naturally and closest to the natural language that the team uses to describe the problems and the processes. Now, I want to talk about authentication authorization because this question comes up all the time. And just to be clear, authentication refers to who you are, and authorization refers to what you have permission to do. Where do authentication and authorization happen in GraphQL? And the answer is it doesn't happen in GraphQL at all. And I can prove it to you by contradiction. So this is our architecture. We have, let's say, a REST API, GraphQL API, and an RPC API, and they come over HTTP and custom TCP respectively. And let's say that authentication happens at the HTTP layer and the TCP layer. And what we've done here is we put the authorization logic next to the business logic. And notice that the business logic is not the same as REST, GraphQL, and RPC. Those are merely implementation details for how to get at the business logic. Why does authorization have to live here? Because it is business logic. If you move authorization into GraphQL, this is what you get. But what about authorization for REST and RPC? You'd either have to copy paste the code or you'd end up with bugs. It's just not pretty. So make sure that the authorization logic lives in the business logic layer. It's not a GraphQL problem. Now, at this point, you might be wondering, if you like what you've seen so far, you might be wondering, when is the best time to use GraphQL? It's got a lot of upfront costs. It's a piece of new technology. The team has to learn it. When is it worth paying that cost? And to answer this question, I'm going to steal a great idea from Martin Fowler. He calls this the design stamina hypothesis. And he says that, well, what's the point of good design? Why do good design at all, or documentation, or invest in software architecture? And the reason is because if you go with no design, the time it takes to add the same amount of cumulative functionality decreases over time as the weight of the code base bears down on itself. Consequently, if you invest in good design, you can delay that. And of course, whenever you have these two curvy lines, you can draw a horizontal line through it and you get this design payoff line. And what Martin is saying is The design, beyond the design payoff line, invest in good design. Before the design payoff line, do not invest in good design. And by the way, the design payoff line is probably behind you. So this is a really useful mental model to think about all sorts of different things that we do, and to find out that a lot of the things that we do is wasteful, but I think this model is really relevant for GraphQL. Now I mentioned we're going to talk about getting GraphQL into production. How you get into production is a bit of an art. And here are some general do's and do nots. So do not build the entire schema up front. I know it's very tempting to look at your business domain problem and go, oh, okay, we can turn this into a GraphQL schema all in one go and then replace the REST API. No, don't do that either. Start slow, build one query, build the minimum useful piece of functionality, and then gradually expand it. Incremental is the way to win. Do not place business logic in the GraphQL layer, just like I was saying why you shouldn't place authorization logic in the GraphQL layer, because business logic is transport agnostic. Where in the business logic does it say it has to use TCP or UDP? Where in the business logic does it say it has to use HTTP? It doesn't, and it shouldn't. So keep the layers focused on what they need to do. However, you should educate the entire team. And this involves the entire team, really. It involves the program managers, the testers, the security personnel, the program managers. I mentioned that already, the engineering managers. Everyone needs to know what this means, because this has deep implications up and down the stack, all the way from the client back to the server, even to the database. You want to choose a solution that fits with your stack. I mentioned that the reference implementation is in JavaScript. That doesn't mean that you have to use the reference implementation. In fact, there are a lot of features that other implementations, for example, GraphQL Java, implement before the reference implementation. So you definitely want to take a look at those other services that you're more familiar operating. And then finally, I said, build the simplest query first, make it read-only, and then only later should you consider adding in features like authentication and mutations, and then gradually expand the schema over time. We don't really have time to go over this, but GraphQL is great as an API gateway and many other use cases. And of course, we need to call out the fact that there is a service on AWS called Appsync that basically deals with a lot of these problems for you. Take, for example, subscriptions. Subscriptions, unlike queries and mutations, are stateful. And as a result, you need to be able to scale a real-time gateway, something like a WebSocket fleet. That's a huge challenge. And if you want that, and you don't want to deal with the burden of scaling your own real-time gateway, you need to check out Appsync, because it does all of this for you. And it also connects all of your resolvers with Lambda functions. It is an excellent piece of it is an excellent service if you're getting started with GraphQL, and you should definitely check it out. And we also have, of course, a couple of other links here. Apollo, this is a very popular GraphQL client and server. Hasura, another very important player in the GraphQL space. And then I also have a couple of resources here if you want to take a look at how to get started with GraphQL. You want to contribute to the community. And then this third link here is the demo that we ran at the beginning of the talk for the Star Wars exercise. And of course, we have Appsync here. So that's it. I'm Robert with Amazon Web Services, and I hope that you are now a little bit more familiar with GraphQL than you were half an hour ago. Thank you very much.